Good afternoon. My name is Smriti De. Today I am going to discuss a topic that is load flow analysis in power system. Now let me give the brief introduction of load flow analysis. The load flow analysis or power flow analysis in power system is required to know the state of a power system. Now, mostly this load flow analysis is done to get the information about the power system. So, it is actually the numerical analysis of power flow in a power system network, where we do the assessment of the steady state condition of a power system network. So with this load flow analysis we will be able to know the voltage, magnitude, phase angles at each buses of a power system network. Also the line power flows through the power system or transmission lines of a power system. And once we know the line power flows, then we will be able to get the total system losses in the network. Now this load flow involves the iterative techniques like Newton-Raphson load flow method, Gauss-Seidel method to do the analysis of the power system. Now moving forward, why there is a need or importance of load flow or power flow studies. Now load flow studies are very important or helpful when making future plan by considering and analyzing various hypothetical situations related to power system network. For example, through a load flow study, suppose we want to remove a line for maintenance purpose. So in that case, whether the existing lines will be able to supply the required demand or maintain the network security or not, that we can get with the help of load flow analysis. How? We will remove a line from the system, and with the given with the existing condition or loading condition, we will see will run a load flow method to get the information of the power system network, and from the output we can see whether the voltage, whether there is any voltage violation or any line flow limit violations are there or not. So this method of power flow study, or we can say this load flow study, will give us that get this information. Now as we know that the load flow analysis or load flow study give us information about voltage magnitude, voltage phase angle on each bus under steady state conditions, and this is important because the magnitude of the bus voltage must be maintained within a defined limit. Otherwise, what will happen? Voltage collapse or voltage stability problem will arise. So as with the help of load flow we are getting this information, then we can, by seeing the situation, we can take the necessary action or adjustment to bring the voltage back to its specified limit, or the control measures can be taken if required. So these are the importance of load flow analysis in power system. Now, in load flow studies, the power system planning engineers must know this information, such as the voltage levels at all the buses during the operation, and the power system elements, conditions of the power system elements, whether they are overloaded or they are in a stable position, that power system planning engineers must know, or and the weakest point of the system, like if there is any limit violation, for example, if there is any voltage violation or line flow limit violation, that power system planning engineers must know after this study or in load flow study. So based on this, if we want to make some necessary uh, changes in the power system layout, that also can be done with the help of load flow analysis, like upgrading the transmission lines, or maybe future expansion of the power system network. So in that case, load flow analysis is essential. Now, how to perform a load flow study or load flow analysis? Uh, First of all, we should have a power system network for which we will do the load flow analysis. So modeling of the power system network is necessary. Then next, development of the load flow equations are necessary. And once we have the load flow equations, by solving the equations we will be able to get the information of all these electrical parameters. So here let's moving forward. What are the power flow or load flow equations? Now let's consider a 3-bus network where we'll have two generator bus or two generators and one bus where load is connected at bus number 3. So if we want to form the static load flow equation, then we will have to uh, find out what is the current injection at any node of the system. So this expression is given by this equation number 1. Similarly, uh, we can get the what is the power injection at any node, like ith node, I complex power injection, that is represented by this expression. So here what is this Vj is the voltage magnitude at node or bus j, and Yij is the line admittance. This actually the is the element of line admittance matrix. Here G and B are the conductance and the susceptance of the transmission line, and here this V is the having some magnitude as well as angle. So after putting all this here, we will be getting the load flow equations, two load flow equations, Pi and Qi. So here we can see this equation number 5 and equation number 6, which represents the power injection at node I, and these are the non-linear equations. Why? Because this consists of sine and cos terms. So these non-linear equations of power flow we have, and if we see these equations, we can see here we have four variables. So each bus having four variables, that is active power, reactive power, voltage magnitude, as well as phase angle. Now if we want to solve these equations with using the nonlinear iterative techniques, we have some problem, we'll face a problem. Suppose we have a 3-bus network where will have 6 equations and 12 variables which are unknown. So it's not possible to determine or find out 12 unknown variables from 6 equations. So what we have to do, we have to reduce the number of variables by assuming some known variables, or by assuming some values of the variables which are called known variables. Now how we'll do, we will actually here reduce the unknown variables which were 12, will reduce it to 6 by classifying the buses into two categories. One is generator bus, another is load bus. Now what is this generator bus actually? Is a bus where the generator will be connected, and this is also called PV bus. Why? Because for this bus we make, or we assume P and V are the known parameter of that bus and others are unknown. So now for 3 bus network we'll have 6 known variables and 6 unknown variables. Also we have 6 equations. Now we can calculate the unknown variables for the generator bus. Same way for the load bus. Now what is that load bus actually? Load bus is the bus where the load will be connected. So that is the load bus. Now while going to the classification of the buses, we can see here there are 3 types of buses. Now what is this actually, how it is coming? Another bus which is called slack bus. So let me explain one by one. As I said, the load bus is the bus where load is connected and that bus power injections, real and reactive power, will be the known quantity or specified quantity, and unknown quantities for that bus will be V and delta. Most of the buses in power system network are of this bus, almost 85%. And the generator, as I already have mentioned, the generator bus is the one where the generator will be connected. So for that bus, P and V are known. 15% buses only are of this type. This bus is also called voltage control bus. Why? Because we can control the voltage by controlling the reactive power through the voltage regulator, and we can make voltage as constant. So also this P, active power, can be controlled with the help of prime mover input. So this way the reactive power and delta is unknown for this bus, and this is also called PV bus, where P and V are known and Q and delta are unknown. So this voltage control bus may not contain any generator in this. Where SVC or tap changer are connected, that is also called a voltage control bus.